In this video, we're going to talk about impact. In particular, we're going to talk about central impact. And we're going to use these equations, the coefficient of restitution, which is the velocity of B2 minus velocity of A2 divided by the velocity of A1 minus velocity of B1, where of course 1 indicates the initial velocities of each and 2 the final velocities. And we're also going to need conservation momentum, mass of A times the initial velocity of A, mass of B times the initial velocity of B, mass of A times final velocity of A, mass of B times final velocity of B. And in many cases, we're going to need conservation of energy. Now here, the V's, I made them a little bit different. These are potential energies, and the T1 and T2 are kinetic energies. Now I'm going to start with a very basic example. And if you want a more advanced example, you can go ahead and jump ahead to some of the other ones in this video. But this one's very basic. Determine the coefficient of restitution E between block A and block B. Again, we're assuming no friction. And so block A starts with 10 meters per second to the right, B 4 meters per second to the left. Velocity of A after impact is 2 meters per second to the right, and B is 6 meters per second to the right. So again, when we do this, we'll have to define maybe call to the right positive. And let's look at our velocities. Our initial velocity for A is going to be 10 meters per second to work on the right positive, so I'll be positive. Velocity of B, the initial is to the left, so we'll call that negative 4 meters per second. Velocity after impact, velocity of A is going to be 2 meters per second to the right. And you see velocity of B is 6 meters per second to the right. So those would be positive. So go ahead and put those into the equation for coefficient restitution. And remember that is E BB2 BA2 divided by BA1 minus BB1, like that. And just put your values in. 6, I won't put the units in here because they're all meters per second. 6 minus 2 divided by 10 minus a minus 4. So it's going to be 4 divided by 14. If you put that in your calculator, that's going to give you around 0.286. And that's the coefficient restitution of this event. So let's take a look at this problem here. This has a few more features in it. 2 freight cars impact. The coefficient restitution of the bumpers is 0.7. We have this freight car going to the right 10 meters per second, this one to the left 12 meters per second. And this one, A, is 10,000 kilograms or 10 megagrams. And this one is 20,000 kilograms or 20 megagrams. So what's the velocity of each car just after impact? So we're going to take a look at this. Now, the equations we're going to need are the coefficient restitution equation and conservation momentum. And let's go ahead and see what we have here. The velocity of A before impact. Again, if we call to the right positive, this is 10 meters per second. And the velocity of B before impact is 12 meters per second. It's going to the left, we're going to call that negative. And so, if you look at this, we're gonna have a couple of unknowns. We know the mass of A, the mass of B, so those we can fill in. We know the velocity of A and B before impact, but we don't know the velocity of A and B after impact. So therefore, we're gonna have to use both these equations since we have two unknowns. So let's see if we can fill in some things here. Let's maybe start with this equation here. So let's fill in what we can. The mass of A is 10,000. The mass of the velocity of A before impact is 10 meters per second. Mass of B is 20,000 kilograms. Velocity of B is 12 meters per second. And they're gonna have to use another line here for the right-hand side. So again, we're gonna have 10,000 times VA2, which we don't know. And plus 20,000. VB2. I'll just assume that they're both positive, going to the right. I'll leave them as positive. Then we can see from the sign of our answer what we'll end up with. So we're going to have to, again, we have both these unknowns. So the best we can do is kind of find a relationship between these two variables. Now this left-hand side here comes out to be minus 140,000. That, so I'll write it like that if you'll allow me to do that. And then let's maybe bring this to the other side. So that'll give us, say, negative 20,000. Like this, and then what we can do, we could solve for VA2 in terms of VB2. And actually, this should be VB2 here. Please fix that. So again, we'll divide then both sides by 10,000. So when we divide both sides by the 10,000 kilograms, we end up with VA2 is negative 2 VB minus 14. Now we can use the equation for our coefficient restitution over here. And we know that our coefficient restitution was 0.7. We can put that in here. And then we know VA1 was 10 meters per second. And VB1 was minus 12 meters per second. And now we can use this to find, say, VB2 minus VA2. So this is going to be 0.7 VB2 minus VA2 divided by 22 like this. And then 22 times 0.7 is 15.4. So now we have two equations and two unknowns. We have this equation up here that we found. Oh, it's equation 1. Oh, it's equation 2. And you can solve these almost any way that you choose. I'm not sure which way you like to do this. Like, let me solve for VB2 here. VB2 is going to be 15.4 plus VA2 would be one way that we could do this. And then you can substitute this back into equation 1. Okay, we'll put this up into here. I'll leave off the units for the moment just to make it a little bit less cluttery. So again, after we substituted and multiplied this out, we get this minus this. Then we can bring this to the left. And over here, we're going to have what? Minus 44.8, like this. And divide that by 3. This. And then that'll give us a velocity of A after impact. Now we want the velocity of B after impact. We can use this equation here. And so it'll be B2 equals 15.4 minus VA2, 14.93. And VB2 has a velocity of 0.067 meters per second. Quite interesting. So then after impact, the velocity of A was negative. So it should be going to the left. And the velocity of B is positive. So that's going to be going to the right. This. So let's take a look at this problem. We have a smooth ramp. We have a package A, which is 40 pounds, starting at 8 feet per second. And it slides down the smooth ramp 15 feet. It impacts B. And B is at rest. The coefficient of restitution between A and B is 0.65. What's the velocity of A and B just after impact? So let's take a look at this. we're gonna have to use several equations in this. Now, first of all, we're gonna need to know what the velocity of A is just before impact. So we're gonna have to use conservation of energy to find that. And we're gonna have to set like a datum line. Let's call up here where A starts, let's call this the datum line. Remember, you need that when you're doing conservation of energy. And let's put our values in. So again, remember our equation for conservation of energy. T1 kinetic energy, V1 potential energy, T2 kinetic, V2 potential. Again, this is going to be 1/2 m v initial squared plus the potential energy. Remember, that's going to be like our weight times our distance above the datum line. Now, this case is going to be 0 when we're starting here. And then 1/2 mv2 squared. And I should maybe call this a y1 and call this a y2 here. So again, this is going to be the distance above the datum line. Now, we're starting at the datum line at A. So we're starting up here. This y is going to be 0 because it's right on the datum line. And then for 1/2, our mass is going to be 40 pounds divided by 32.17, which is acceleration due to gravity. And its velocity is starting out at 8 feet per second. I should have put some units on here. Plus 0. And on the right-hand side, we're going to have 1/2. The mass is still the same. Velocity 2 squared. Now, at this point, the mass is going to be 15 feet below the datum line. So that's going to be our 40 pounds times a negative 15 feet below the datum line. So we have an equation like this. Left-hand side, this is 39.75. I've got getting in a bad habit here. I should have put units here, but let's continue on. And this is going to be 0.62 V2 squared. And it's going to be minus 600. And now let's solve for V2. I'm going to kind of rearrange things a little here. You'll bring this over to here and then kind of reverse the equal sign. So this would be 639.75 like this, and divide by 0.2. That's going to be 0.62. So the velocity at 2 squared is going to be the square root of 1031. And so velocity 2 is going to be plus or minus 32.1 feet per second. Because remember, when you take the square root, you get a positive and a negative. But in this case here, we know it's not going to be negative because the block is going down this direction, it has to be increasing in speed. So we're going to ignore the negative. So this is the velocity of A just before impact. So now we have the velocity of A just before impact is 32.1 feet per second. Now we're gonna have to use conservation of momentum and the coefficient restitution to solve this, because once again, we have two unknowns. The two unknowns are gonna be the final velocity of B and the final velocity of A. So let's go ahead and use our equation. I'm gonna kind of start again, so I'm gonna call this velocity 1. So again, let's put our equation down so we remember what we're dealing with here. MA1, I should just call that MA, MB, BB1 equals MA2, excuse me, the A2. I don't need to put an A1 or A2, like we don't need to put numbers on the masses because they're not actually changing. And then this is going to be BB2 like this. So again, we know the initial velocity of B is 0. So that term is going to go away. And over here, we have our mass of A, which is 40 pounds. I should again put some units in. 30, you can use 32.2 or 32.17 per second squared. And then the velocity of A just before impact, 32.1 feet per second. Again, this term is going to be 0, so just going to leave that out. And once again, over here, we're going to have the mass of A times the final velocity of A, which we do not know, the mass of B, and the final velocity of B. So once again, we're going to have to reduce this to the point where we have A in terms of B or B in terms of A. I'll fix this up here. This should have been feet per second squared. Of course, I think just said feet per second. Now, if we work this out, we get 39.9. This we get 120, 1.24. Here we get around 3.11. And now let's solve for VA2. And so what we're going to do is we're going to move everything to one side, 39.9. By 3.11. And then we'll divide by the 124. This, and let's see what cancels here. Pound cancels, one of the seconds cancel. And then, so this is going to be feet per second, which is encouraging, which is what we should have right there. So when we divide by the 1.24, we get 32.18 feet per second. And we get 2.51 with no units. Of course, this is gonna be feet per second, so that looks good. So we're gonna work with this equation, and we have two unknowns. So we're gonna need another equation. We'll call this equation 1. We'll get the other equation from our coefficient of restitution. Remember, that's going to be E equals VB2 minus VA2 divided by VA1 minus VB1. And now in our case here, VA1 was 32.1 feet per second, and VB1 was 0. And now also our coefficient of restitution in our case was 0.65, so we can put that in here. And then this just weigh 32.1. So on the left-hand side, we're gonna have 0.65 times 32.1, which is 20.87 feet per second equals VB2 minus VA2. And now we can, I'm not sure which one you want to solve for. Let's maybe solve for VB2. And when we move that to the other side, that's going to be positive, isn't it? So we're going to have an equation such as this. Again, you could have solved it the other way. Solved for VB2, solve for VA2. I'm not sure which is easier, but now we can substitute this into that equation. Substitute into equation 1. And that's going to give us, when we do that, that means VA2 is going to be 32.18 feet per second. And putting it in there is going to be minus 2.51 times 20.87 feet per second. Plus VA2 like this. Now we multiply these two, this is going to give us minus 52.37. Then of course we multiply this over here. So we can put these two together. So VA2 is going to be 32.18 minus the 52.37 gives us minus 20.19 feet per second. And then we multiply this, that's minus 2.51 VA2. So bring this to the other side. That's going to be adding this and this together. That's going to be 3.51 VA2 equals minus 20.19 feet per second. And we divide that by 3.51. We're going to get the final velocity of A. So we divide minus 20.19 divided by 3.51. final velocity of A is going to be minus 5.75 feet per second. And we can find the velocity of B by substituting into here. All I did was substitute into this equation 20.87 plus the velocity of A, which is negative. And if we add those two together, get the final velocity of B to be 15.1. So we end up having then in after impact, we have A up here to be at negative, so A is going this way at 5.75 feet per second. After impact, B going this way, 15.1 feet per second.